Hey everybody, it's Miss Segovia and
Mr. Flint.
we're going to walk you through some of the practice problems for average velocity. The worksheet we're working on right now looks like this. So, the first problem, a student averages 8 meters per second when running a race that is 100 meters long. How long did it take the student to complete the race? Well, we're going to guess, because I know you guys love guessing all the time, but not the guessing that you normally do. We're going to use the guess method. So we're going to start first with our givens. What information comes from the problem? They're telling us that he's averaging 8 meters per second. So what is meters per second? That's our velocity, or speed, because there's no direction with that one, as we learned in the song. 100 meters is referring to, that's right, distance. 100 meters. What's the question asking us for? How long did it take? Well, what's that mean? That is our unknown, so that is time. So what equation can we use to solve this? Well, if you flip through your notebook, you should see that you have the equation for velocity equaling distance over time using all three of these variables. And we can rearrange that one to be time equals distance over velocity. So if we sub in our variables, time is going to equal 100 meters over our velocity of 8 meters per second. And then we solve, time is going to equal 12.5 seconds, because our meters will cancel out and seconds will survive. So your final answer is time equals 12.5 seconds.
All right, now it's time for question number 3. An airplane flies 1,800 meters in 18 seconds. What is the average speed of the airplane? So we can look at our numbers, and we've got 1,800 meters, and we have 18 seconds. So these are our givens. So let's come down and list our givens. Okay, 1,800 meters. And we see it's in meters. And using your flashcards that you made, anything in meters would tell us a distance. And then also using your flashcards, you can see anything that's measured in seconds is going to give us a time. Now, the problem's asking for what is the speed, so that is our unknown. We don't know speed. And speed has the same abbreviation as velocity, just a v. But we know speed, there is no direction. Now, let's find an equation that has both distance, time, and speed in it. Okay, and we'll see that it is v equals d over t. So then we just plug in our numbers. We just need to substitute and solve. So we'll substitute in our numbers. 1,800 meters for our distance. Okay, so that distance of 1,800 meters gets plugged in here, and your time of 18 seconds gets plugged in on the bottom. So there it is on the bottom. And using your handy dandy calculator, you can see that your answer is going to be 100 meters per second. Now, where do we find these units? Well, you can find them on your flashcards, but we can also cut them out here and paste them over here. We could write it as 100 meters per second too. That's usually difficult for textbooks to write it that way, so we usually see it written out the first way that I wrote it, horizontally rather than vertically, 100 meters per second. And we go through the guess method, not just to torture you, but because in AP Physics you are going to have to show your work on free response problems. So that's why we are doing this, showing you a method where you show your work and you can get full points on some of your future questions in AP Physics and also AP Chem.
The torturing's just a bonus. Alright, a student travels east at a speed of 5 meters per second for 3 seconds. The student immediately travels west at a speed of 5 meters per second for 3 seconds. Determine the following for this trip and let east be considered positive. So I got the long one here. My gosh, 4 different parts. Make it look like one question. It's a lie. There's lots going on here. So let's draw a little picture of it just so we can visualize this one better. Here's our happy little guy. He wants to go to the east. So he's going to travel east for 5 meters per second and for 3 seconds. So if he's traveling east at 5 meters per second for 3 seconds, we know we can just work that one in our head how far he's going, but of course we have to use the guess method to show how far he goes in this direction. So let's list out our variables. I'm going to put them down here at the bottom because we're going to refer back to them for several problems. So our givens for this problem, we have our first velocity of 5 meters per second, and we have our first time is 3 seconds. Then they give us the other direction, so we're going to call that velocity 2. And they say, since they're saying east can be considered positive, that means we're going to consider west negative for right now, and we're going to call that 5 meters per second. And the time for that one is also 3 seconds. So right now the unknowns we have, they're asking us this first one, the distance. We don't know the distance. Our unknown is the distance for the first trip and the distance for the second trip. So if we want to plug these numbers in to solve them over here for letter A, our distance 1 is going to be our velocity of the first one times our time of the first one. So we get V1 times T1. So we're going to have 5 meters per second times 3 seconds. And so the distance of the first time he travels out is 15 seconds. Because again, 15 meters, my bad, because we're going to cancel out our seconds up in our problem. In the second half of that one, he's traveling the other direction, so D2 is our second velocity times our second time. And I know you guys are thinking, Miss, they already did 5 and 3, 5 and 3, we can figure it out, but not every problem is going to have the same numbers going out and then coming back. So we've got to work through it just for demonstration purposes. And that torturing thing comes in too, which like to bug you. So 5 meters per second, 3 seconds, and so in this one, he's traveling back 15 meters. Now, that doesn't mean he's necessarily canceling out. That just means he's traveling the other direction. So if we look at the displacement, he's going out here 15 meters, but then he's traveling back, again, another 15 meters. So our student's total displacement is actually going to be 0 meters, since he went out and he came back at the same. So you can actually, for displacement here, you can take our distance 1 plus distance 2, and in this example, it's 15 plus a negative 15, so our total displacement is 0 meters. If you wanted to graph it too, you'd also end up with a graph that looks like a lovely little mountain. He would go out at about a 5 meter per second and then back at a 5 meter per second. So let's look at the speed. The average speed of this one, remember speed, we can use velocity, is our total distance over our total time. So in this case, we're going to have our total distance traveled is 30 meters, because he still traveled 15 meters this way and then 15 meters back the other way. He went 30 meters even though he really ended up nowhere. It's like running on a treadmill. You're not going to go anywhere. So our average velocity, it's 30 meters over our total time, which is 6 seconds. 30 meters over 6, plug that into your calculator, and you're going to get 5 meters per second. Again, you can just cut our symbols right out here, put them down there. So our final answer for C is 5 meters per second. Now this is the student's average speed. The next one is the student's average velocity. So how's that different? Well, the velocity is referring to our position. So we've got our average velocity equals, our displacement, how far we got displaced, which we saw over here was 0 meters. Our displacement is 0 meters. our displacement over our time. So our displacement happened to be 0 meters over a total time of 6 seconds. So the student's average velocity over the course of this one was 0 meters per second.
Oh my goodness, you talk a lot.
Yes, I do. It's a talent I have.
All right, so now it's my turn to talk a lot. Here is a challenge problem. And this one will be most likely going to be given for some kind of bonus on a future exam if you're able to do this one. This is getting it's a 3-star. You're getting super close to an AP type question here. So I'm just going to cover this one real quickly with you here. Quickly being in quotes. All right, so ready, set, go. A car tests a new engine by traveling a straight course a distance of 1,500 meters. During the first half of the course, the car averages a speed of 10 meters per second, and during the second half of the course, the car averages a speed of 30 meters per second. What is the car's average speed for the entire course? So, first off, you have to realize that our course is divided into a first half, and if we have one half, that implies there's going to be a second half. 2 halves make a whole, so they finish the race there. All right, so the entire race course was 1,500 meters. So if the entire race course was 1,500 meters, then how far did the person go during the first half? Well, then we'd have to divide this by, you guessed it, 2. And we would see the first half of the course is 750 meters long. So our let's see, since we're using speed, let's not use displacement, let's use distance. So our distance is 750 meters. And then the speed for the first half is an average speed, and it is 10 meters per second. Okay. And so these are our givens so far. These are the givens. This is G here. But now let's come over here and we'll do G for the second half. We know the distance is still 750 meters. Half of 1,500 is 750. And then the average speed has changed. It is now 30 meters per second. So those are givens. Now, they're really asking us, let's get back to what in the world were they asking us to find? What is the car's average speed for the entire course? Well, if you want to do average speed, okay, average speed, we need to know the total distance, just like in the previous problem, or problem number 3, I should say. We need to know total distance, and I'm running out of room there. There we go. Distance over total time. Right. So we know the total distance. The total distance that the car is moving is 1,500 meters. That's the distance for the entire track. But we do not know the total time. How long was that car on the track for? So we've got to figure that out, come back, and we're going to plug it in here. So we've got 1,500 meters, and we're going to plug in the total time there. Well, let's come back here, and we can figure out the time for the first half of the course by rearranging our velocity equation to solve for time. So that's distance over velocity. And let's plug in our numbers. Our total distance, 750 meters over 10 meters per second, gives us a time of 75 seconds. Do the same thing over here. Time, distance over speed, and the distance being 750 meters. Speed is now, speed up, instantly made it to 30 meters per second. And it should be 25.
Okay, now that you have this information, see if you can work the rest of the problem. Check the bonus video to see if you got it right.